guys, I started a recording session. These recordings we cannot access directly through the link. Why? Because it's a Microsoft related. Only my organization people can able to access. Means Microsoft account, with the account only we can able to access. Office 365 account is required. Okay, but I will put all the videos usually into here. So I will give you how to access. I will tell how to access, and also I will put it in a Google Drive, so then you can able to access. Google Drive thing only it will be available for 1 or 2 days only. After 2 days I will delete the old one because I don't have a space. Okay, so the question is, what is network? So it's here the name like a basic networking or basics of networking, whatever the name or networking essentials. It is not that much simple. Okay, there is a lot of statements you should remember. So what is network? What is networking? Is networking, and what is internetwork, and what is internetworking? Okay, so this is the defines it here. It is interconnection of two or more devices. Interconnection of two or more devices is called as network. Okay, it meaning is, if you go to the page, I have a PCs, I have a computers are there. Okay, so like I have a PCs. This is my PC. This is another PC. Okay, for example, now you are connected directly or through some device. Okay, or maybe you have a switch or a hub. You're connected like this. Okay, or like this. So whatsoever it is, how you connect is a different point. But you, whenever you make a connection, okay, whenever you make a connection like this or like this, or directly you are connecting, it is just a connection. Two or more devices. So you can have a more devices, so you can able to connect it. Okay, so that is called a network. Interconnection of two or more device is called a network. The device not only a computers, also switches, routers, laptops, mobile phones, okay, printers, scanners. So that's why it is saying devices, not a computers. Okay, device means any device which can able to connect to the network. It's able to connect to the network. That is called a, we are saying networking devices. Okay, so interconnection of two or more devices is called a network. Next, networking. I am connected a devices. I am connected the devices together, but I make sure they should communicate each other. Okay, they should communicate each other. If they communicate each other, so that is called a networking. That is called a networking. If you connect, that is called a network. If they are communicating, networking. Okay. Now I have a network like this. I have a network like this, and I have another network. Maybe I have another network. Maybe same as our network or different than our network. Whatever it is, I have another network. This is another network. It's my second network. Like that, I have a multiple networks. Two or more networks are there. So whenever you try to connect these network together, so this is called a internetwork. It means connection of two or more networks. We call it as a internetwork. Internetwork is connection of two or more networks. You have a network. and you have a network. So you have a network and you have a network, and you make a connection between two networks, that is called a internetwork. Internetwork. Next, internetworking means communication between different networks. So whenever you communicate from this device, for example, this is A, this is B. So when you are communicating from A to B, okay, when you are communicating from A to B, so that is called a internetworking, because A PC in a one network, B PC in a different network. So whenever these devices are communicating each other, even though they are in a different networks, they are communicating each other. That is called a internetworking. Guys, understand the difference between network and networking.
Yes.
Very.
Yes, sir.
So
Yes,
it
sir.
is very simple to say network and networking. Network, to understand, very simple single word way, connection. Okay? Connection or a connecting. Connection or a connecting. Physical connection. Network usually like it is a connection or a connecting. So we need a physical connection. So it's a connecting or a physical connection. Okay, means how you connect. That's the different point. Okay, so you are connected. That's called a network. Networking. You are connected, but we need a communication, right? So you have a two PCs. You took a wire and you connected both, but they both PCs are not sharing anything. They're connected, but they're not sharing anything. So what happened? Nothing. Okay, so we don't call that one as a networking, right? So what is networking? Communication.
Communication.
Communication is there, then only it is
Networking.
okay. So for networking, we need a physical connection and as well as other things also there. So that is called a logical addresses and protocols. Protocols to communicate. Okay, we need a logical addresses and protocols to communication. So like how to address someone, right? So here it is, Alekia is there. So I want to communicate with Alekia. So we are connected, but we have to communicate. So how to communicate? So I have to tell hi Alekia. So what is networking? Like that. So I am asking a question and she will reply. So that's like we have to address first, address the destination and use a protocol to how to communicate. So what are you communicating? Are you about the details or anything like that? Okay. So logical addresses and protocols are important in the networking. Internetworking means internetwork usually like connection of two or more networks. Internetworking communication between two or more networks called as a internetworking. But physical and logical network and networking. So it's a very simple and very sensitive point. That's why I put it simple. This is the answer, but this is for understanding very easily, like so the dead straight point it is. Okay. The next one, yeah, different type of networks are there. So different type of networks. Before going to that one, anyway, I came to this network and physical connection kind of stuff. So I want to tell about this physical connection. So because we are already here, so you have a devices, and how to connect these two devices is how to connect physically these devices to make it communicate. Okay, later communication will come up, but first of all we should connect it. We should connect it. So that based on that we call it as a physical topologies. Yes, actually spelling is correct. Okay. So based on the connection, based on the way of connecting devices, we call that one as a physical topologies. Okay. So what are the different physical topologies? Are a bus topology, ring topology, mesh topology, star topology, point to point topology. So there is a point to point P2P topology is also there. Point to point topology. Okay. Point to multi-point topology. Point to multi-point topology. Hub and spoke topology. Okay. Spoke and leaf topology. Like so, there is a certain different topologies are there, but main topologies are these things only. Okay. Hybrid. Hybrid topologies like this. So we'll see one by one how bus topologies look like. Okay. So these are the devices. You know, earlier days we have a cable TV network. The cable guy take a very big cable and put the cable in the entire street like this. Okay. And then from the cable, okay, from the cable there is a connection to our TVs directly. Similarly, this topology is like that only. So it is a very easy to configure. Okay, it is very easy to configure and very cheap. Very cheap also. For example, this is my PCA B, C, D, and we have a backbone wire. So the wire we call it as a backbone wire. This is backbone wire. Devices are connected directly to the backbone wire. It is very simple, right? So take a one cable, connect all the cables to that one. So usually we use a coaxial cable here. Okay. And so T connector, we use a BNC connector. So and we T connector and connected to our systems directly. It is very easy to configure, very cheap configuration also, means very less cost. That is a bus topology. What is a bus topology? There is a backbone wire and devices are connected to the backbone wire. But problem is there. So always why we are not using this one is also there is always a issue, a problem or something will be there. That's why we don't use that one. Okay. So if in case line is broken at some point, so there is a lot of possibility, right? Wire will be cut. So what happened here? What happened? The line is broken here. So obviously A to B communication is there, but A to B to C and D communication won't happen. A and B cannot communicate C and D. Why? Because of line is broken. Again, you have to search for where the broken is occur. Again, we have to repair the broken, and it is very difficult to find where broken is occur. Okay. Still, there is a certain organizations, certain government or a very old computer system places like in naval kind of stuff. Still, there are using a coaxial cables and these kind of network connections also there. Okay, but in generally, generally we don't use the bus topology currently. Okay, so I just put a coverage here. Okay, this is the bus topology. Next one is ring topology. I'll put here. So I want to put all the things into one place only. So then easily you can understand the differences. These are the standard topologies. So that's why. Guys, again, these are my devices. If you feel the picture is very small size, then I will put a very big one. No problem. See, here it is. This is A is connected to B. Okay. A is connected to B and B is connected to C and C is connected to D. D is connected to E. E is connected to A again. It means if A want to send a packet to D, okay, A want to send a packet to D or C. Okay, for example, I take a D. First, A send packet to B. B send that packet to C. C send a packet to D. Okay. So like this, either clockwise or anti-clockwise, the communication is there. How it is happens? You have to go to each and every PC and you have to tell how they are connected and how they should communicate. Okay, how they should communicate. That is, you have to define, you have to program on each and every PC how they should communicate. So this is called a ring topology. It's a closed loop one. Okay, so A to B, B to C, C to D, D to E, like that. So you want to send a packet to B, E will send to A will send to B. Okay, so sometimes it will be delay. Sometimes wire is disconnected, wire is having some problem, wire got disconnected here. Communication may stops. Communication may stops. So understand what I have done. So I disconnected at C to D. So packet go up to C, but C to D is communication will stop. Even though there is other side of connection is there, they won't communicate. What is the solution? The solution is redundancy type. Means I make a two connections in a reverse order. Here I configure these connections with a anti-clockwise wise, like this. E to E, E to D, okay, D to C, C to B, B to A, like this, clockwise and anti-clockwise. I'm connecting it. Got the point, guys? So this is called a double ring topology. Of course, this is a ring topology. I didn't put a heading. Okay, this is ring topology, and now we have a two rings in that one. That is called a double ring topology. Ring topology means single ring. Okay, double ring means so two rings are there. One ring clockwise, another ring is anti-clockwise. This will solve the problem like which one is near to me. So based on that, I will calculate. I will communicate with that. Means A to D communication directly happens. A, E, D like that. Okay, directly A send packet to E, E send a packet to D. Earlier what happened? A has to send a packet to B, B to C, C to D. That is earlier. Now because of this double ring, I can directly send a packet to D. Next, if line is broken like this, C to D communication is stopped. C to D communication is stopped, but it can send through like this redirection C, B, A, E, D. It will reach finally. Understand, guys? C to D, wire is broken, but C will send a packet like a C, B, A, E, D like this. Okay, so that is the advantage of double ring. But there is another problem is scalability problem is there. Scalability problem. Redundancy was okay, but scalability is little difficult. Its meaning is if I add one more PC, what happen? Again, I have to insert into this loop, right? So I have to disconnect A to B and connect it to this PC, and I have to go to each and every PC. I have to tell about the new path. Okay, how to communicate? I have to define in every devices. It's not automatically adjust. I have to go to each and every device. I have to tell how to reach the destination. It's difficult to scalable. What is scalability?
Excuse me,
Yeah,
sir.
yeah, tell me, tell me.
Sir, what is the topology itself?
Which topology?
Sir, what is the topology itself?
This topology.
So topology only.
What is the meaning of topology?
Yes, sir.
The topology means it's like how you connect, how it is there, how it is connected or established.
Okay, sir.
Otherwise, very simple. Geometric properties and spatial relations unaffected by continuous change of shape or a change of figure. So how it is connected, how it is arranged. This exactly say it is how it is arranged. That's a topology. Very good question. So that is also one question. Okay, topology means how it is arranged, how it is there, how it is look like, how what is the shape. Okay, how it is connected. Very good. Okay, so this is ring topology. Next one. This topology everybody will identify. So usually in every class I will ask this question, so people will tell easily answer. Okay. So which topology it is?
Star.
Star.
Very good. See, I
So
told no, so
actually,
everybody will tell answer.
we have
Everybody will tell
started.
answer, but it's not star topology, that is mesh topology. Just I'm directly telling what is the topology and how it is look like. When I'm telling explaining, right? So that points you have to add up. Okay. So guys, again, PCA, PCB, PCC, PCD, PCE. Okay. I took a 5 PCs here, but if you see, A is connected to B, C, D, E also. Means a device is connected to every device, every other device. Okay. If you see how many wires are there, like a D, 1, 2, 3, 4. Look at here. From D, how many are there? This is 1, 2, 3, 4. Means each device must have total devices minus 1. 5 devices are there. 5 devices are there. So minus 1, 4. 4 wires or 4 connections must be there. So that is okay, your mesh topology here. So what is the mesh topology? Every device is connected to every other devices. So A is connected to E, D, C, B. B is connected to A, C, D, E, like that. So what is the advantage of this one? For example, if line is broken here, no problem. So devices will communicate each other. Device is down, no problem. All other devices will communicate each other. Okay. A device is down, no problem. A line is broken, no problem. Okay. It is a highly redundant topology. Okay, so redundant topology, highly redundant. What is highly redundant topology means? Whatever the line is broken or a system is down, still no problem. All other communication is keep going. Unlike your bus topology and ring topology, okay, it's a highly redundant topology. Okay, so where we use this type of redundancy, so where we use this kind of redundancy in a core networking type places, data centers, server related. Okay, so I put a data centers, quite easy. Data center servers, storage devices, servers, storage related. In data centers, storage related. In that places, mesh topology is common because redundancy is important there. Redundancy is important, but it is a complex. But it is a complex. Bus topology simple. Mesh topology complex. It's a complex. A lot of wires are required. Lot of wires are required. Think it is 5 computers, and these are the wires. Like how many wires are there? You can count. Like this is the 1 wire, 2 wire, 3 wire, fourth wire, and fifth wire, 6, 7, 8, 9, 10. Almost I counted 10 wires here. Okay, 10 wires. Think about you have a 20 computers. This 5 computers, 10 wires. 20 computers, maybe 40 wires. Okay, 40 means 20 computers means each computer should have a 19 connections. 19 connections. Okay, so it is costly and complex. There is a 2 problems. One is costly and complex. But one more is there, that is called a scalable problem. Not easy scalable. Okay, not scalable is better. Okay, so what is this scalability? Again, I'm telling. So already I told, but I'm telling. What is scalability? Extending the topology, extending your existing topology. Okay, for example, I attached another PC. For example, F. Now what I have to do? Again, you have to go to each and every PC. Start connecting to FPC. It means every PC hardware should be upgraded. Again, wire should be connected and start communicating with that one. It's a costly and very difficult to scalable. Not easy scalable. It is not exactly, I didn't put it, but it is not easy scalable. It's not much easy. Mesh topology, not easy, but it is highly redundant. Means any device is failure or a connection is failure, no problem. Remaining communication is keep going on. Okay, very useful at a core networking places. Data center, servers to server communication, server to storage communication. In that places, mesh topology is very useful. Okay, when you are looking the star, we think it is a star topology, but star topology is different. So I will write the star topology here only, small space, but I will explain it star topology again in a big space. This is the star topology. So I will use small box in between. Very good. Okay, like this. There is a centralized device which connects our devices directly. Okay, which connects our device directly. Here it is. It is very simple to configure. Again, it is very simple to configure, less cost effective, and moreover, very easy to troubleshoot. Okay, more easy to troubleshoot, but not redundancy. No redundancy at all. Okay, no redundancy. Again, you need a redundancy, so you need a other kind of stuff. This is called a star topology. What is the star topology? There is a centralized device, either it is hub or a switch. The device name is hub or a switch device is there, and it is connected to all other PCs. For example, A want to communicate it to B. A want to communicate it to B. So how it will communicate? A send a packet to the device like a hub or a switch, and through the switch it reaches the B. A want to communicate to the D. So A to the switch to D. Okay, D want to communicate E. So D to this switch to E. It means all communications are going through a particular device. So what is that device? It's a nothing but a hub or a switch device we are using to communicate. So for example, A want to communicate it to C. A send a packet to you, this switch, and send a packet to C. Okay, like A to C communication will happen. So all communications will go to B to E communication. B send a packet to this switch, and it send a packet to E. So like this communication will happen. And there will be a questions in this one. That's why I said it is not a redundancy, no redundancy. Why no redundancy? Why no redundancy? If this centralized device is failed, if the centralized device is failed, all communication will stop. All communication will stop. The centralized device, switch or hub, not working, no communication. Switch or hub, not working, no communication. Okay. If any device is failure, no problem, all other devices will communicate each other. First of all, if any device is failure, one device is failure, no problem, all other devices will communicate each other. If wire is broken, if this wire is broken, so you cannot able to communicate the particular device because that the connection is broken. But all other communication still goes on, no problem. But if centralized device is failure, entire communication will be stopped. Entire communication will be stopped. So that is the star topology. What is the advantage of using star topology and disadvantage of using star topology? It is scalable. That is the main advantage of star topologies. Scalable, easy to install or easy to configure. It is quite easy to install or a configuration of okay, I will leave like that only. Okay, easy to install, easy to configure. Next, cost effective. It's not cheap, but we are using a centralized device, right? So that's cost is there, but not very costly. Not like you don't need to buy a lot of wires for it. Each device, one single wire is enough. Each device, single wire is enough, right? Only important is we have to use a centralized device, switch or a hub. Should use switch or a hub, we can able to connect it. Easy to troubleshoot. Unlike other topologies, where the problem is occur, we don't know. Like other topologies, like a bus topology, ring topology, mesh topology, some wire is broken, something is happened. We don't know where it is occurred, what is occurred, so we don't know. But in a star topology, we know. A multiple computers unable to communicate each other. A multiple set of computers not working, not communicating, disconnected. Centralized device means switch or hub problem. I have a 10 computers connected to a switch. Switch not working. 10 computers showing no connection symbol. Right? So that is easy to understand. Second, every PC is okay, but only one PC showing a cross connection. So like a no connection symbol. It means that that PC is not connected. Only we can concentrate. We can easily locate on the particular device. On second hand, on the switch and hub, there is a LED blinking is there. Based on that LED indication, we understand there is a connection or no connection. There is a connection or a no connection. Understand, guys? Easy to troubleshoot means. So when the thing is, so how do you understand where the problem is occur in the star topology? How to understand? Hub or a switch, LED indication is there. LED indication is there. I will show you hub or a switch kind of stuff. How it is look like. Networking switches. Yeah, none hours put a because switches. Okay, like this you can see. Switches, hubs, whatever the name you, whatever it is, but both are look like a little bit same. Okay, so these are all LED indicators. You can see there is a LED indicators at on port. These are the physical ports. At the ports or maybe side. Okay, or maybe the side you can see the LED status. Okay, this is on directly. This is a side. You can able to see this side. LED blinking is there. Based on that, you will understand on which connection there is a problem. On which connection what there is a disconnection is happening. Okay, so like that we can easily troubleshoot it. Okay, but no redundancy. What is redundancy? What is redundancy? Very simple. If one server is down, other server will give you services. If one pencil is gone, another pencil is there, you can write it with that one. Okay, like that. If one wire is down, one PC is down, one switch is down, no problem, other will give you services. Okay, that is called a redundancy. So simply it's like having a extra copy, having a extra or a immediate copy of it. So that is called a redundancy is like, okay, if one thing is failure, no problem, still services go on like that. Okay, so that is a very highly redundant is mesh topology, very less redundancy is star topology. Okay, highly scalable topology is star topology, no scalability in a mesh topologies. Okay, and we use star topology. Important thing to understand is star topology, we use it. We use the star topology. We are using this star topology in a regular basis. All networking we are using star topology only. We are not using bus topology, ring topology, mesh topology. We are using star topology. We are using star topologies. Okay, and there is a hybrid topologies already I told, right? So that is we will go. Just I'm going to save this one. No, not this batch, right? So this is the one. Okay, I'm going with other topologies here. Look at here it is. Guys, this is a switch, and this is my PCs are there. Here I connected. This is a star topology. We know the star topology, right? This is a star topology. Okay, so same thing is like this. Okay, so okay, I have another star topology. This is one network. This is another network. I just connected two networks together. Okay, so this is entirely become single network only. So earlier it is network 1 and this is network 2. Two networks are there or two segments are there. Now I connected together, so it is become single network only. It is become single network or a single segment only. Single segment only. So what is this? We call it as single segment or a single network by connecting two networks together. And this topology we call it as a extended star topology. This topology we call it as a extended star. Extended star topology. Extended star topology means combining one star topology to another star topology is called a extended star topology. Okay. So this is what I told, that is scalable. This is also we can say scalability means I have a 10 computers connected to a switch. Now I have a 20 computers. I need more switches. All 20 must be in a same physical network, or maybe 30 computers, or maybe 50 computers, maybe 100 computers. I want to put all these things into a single network. How to become a single network? Okay, because the switches or a hub has a limited number of ports, 16 port, 8 port, 24 port, 48 port, or like that. So each switch has a limited number of ports. Based on the number of ports, number of devices you can able to connect it. Number of devices you can able to connect it. See, this is having a more ports. This is having a very less ports. Depends upon number of ports. So you can able to connect number of devices. If in case you have more devices, less ports are available in a single switch. So what happen? You can take multiple switches. And we can connect them. Okay, we can connect them. So one switch to another switch and become a single network. It is very big one. So no problem. You see here it is. This is my 24 port switch. This is my 24 port switch. So already I given a connection. It means 23 ports are available. 23. Okay. So 23 devices I can connect here. 23 devices I can able to connect it. It means 46 devices can make a communication. Means more than 40 devices you can communicate each other by connecting together. This is the extended star. So this is what we call it as a scalability. Scalability is there in a star topology. What is meaning is you can extend your topology as per the requirement. Guys, understand extended star?
Yes.
Okay. What is extended star? Scalability of your star topology adding another star topology to your topology, then it is extended star, become big network, big single network. Another one is hybrid type of topology. This is a star topology, but I'm also doing mesh topology in it. Means I'm combining mesh topology and star topology together. Why? Star topology will give you redundant scalability. Mesh topology will give you redundancy. For example, I have a servers are there, storage servers are there, data centers, like a core networking things are there. So I need a more redundancy. Redundancy is very important there, and as well as a basic communication is also important. Like client access communication is required, and as well as a if server is failure, and immediately other server will give you a service. So I don't give any chance of anything is failure. Like a cable is not working, still you have to access the services. Okay, or maybe a server is down, no problem, still we have to access the services. It means I need redundancy first. Okay, so I don't give any chance to give a failure. So then that time I will follow the mesh topology. But client access not required a mesh topology to client access. I required just a star topology is enough for them. For people are accessing through network, star topology is enough. But server to server, server to storage, storage to storage communication, or a core network devices communications. Okay, so that required a mesh topology. So like that, it is a mixer topology is called a hybrid topology. What is hybrid? Combination of two or more topologies together, two different topologies together is called a mesh topology. In a mesh topology also there is a one more is there. Our star topology also some people call as a hybrid topology. Mesh and star is actually hybrid topology, but some people tell it is normal star topology is also a hybrid topology. Why? Because of I will tell the story based on that you can understand. Guys, one more topology is there that is called a point-to-point topology. What is this point-to-point? Very simple to understand. When you are connecting a device to another device, other device can be a PC or it can be a switch or a router. Anything can be happens, right? There is a two devices, A device, B device. You are connecting it. So this is point-to-point communication. Okay, point-to-point topologies. Usually, point-to-point topology is used for a serial communications. Is a device to other device connection. Usually, serial type of communication and basically WAN communication, not in a LAN communication. But point-to-point, like this LAN communication, like a PC to PC, you can able to connect it. PC to PC to switch connection, PC to switch connection. Also, we can say point-to-point. You have a switch or a hub, you have a PC, and you connected it. This is also called as a point-to-point only. So anything is connected to anything is point-to-point only. Okay, because this is the one point, this is another point, straight point, right? So that is a point-to-point connection. But in generally, the point-to-point connections are in a WAN communications. This is my router, end user router. So this is my switch. These are the devices. Okay, this is my LAN network. Okay. This is another LAN network. So this is the default gateway, right? This is completely one LAN network. So remember, this is completely one LAN network. This is another LAN network. But these should be communicate through our exchange kind of stuff, right? So I make a communication between these two things is like point to point serial communication. The symbol represents like this. Okay, so this is the serial or a WAN connectivity. WAN connectivity or a serial connectivity. So this is the point to point connector. Okay, point to point communication. Next one is point to multi-point communication. So multi-point communication means different vendors, different connections are there, means from here only you have a different connections are there. For example, I have a different offices are there. So different office means one is in Hyderabad, one is in New Jersey, one is in Sri Lanka, one is in Bangalore, like that. So I have a multiple different places are there. So different point to point communications we are giving. So that's very simple to understand. There's other topologies also available. So I'm not discussing all at that kind of stuff. Okay, so we'll give that points later. This is a multi-point communicator. One single point to multi-points we are connecting. So that is a point to multi-point connector. Ring topology, home topology, so many things are came up nowadays. So point to point topology. See, it is a device to device connection, we can say. See, it is point to point connector. Connection between like this. Point to point means a switch is connected to a switch connection. Router is connected to router, point to point connector. Guys understand? A device is connected to another device directly. That is called a point to point. A device is connected to multiple devices directly. That is point to multi-point connector. So that is simple point to point connector, because nowadays people are asking these type of questions also. That is, so you can say the switch is connected to A and B. It is a multi-point connector here. This switch is connected to another switch. So this is a again point to point connector. This is switch 2. This is a another devices are connected like this. But this is point to point connector. Point to point connector. Point to point connector. But multiple points are connected directly. So that is point to multi-point connector. It is not a standard topology kind of, it's just topology. So usually we use serial communication, WAN communication kind of stuff. Okay. Guys, understood or not?
Yes, sir.
Yes, sir.
Yes, sir, understood.
Any doubts regarding any topology? Bus topology, ring topology, mesh topology, star topology, hybrid topology. Just one or two lines I will give you for each and everything. So bus topology, devices connected to backbone wire. easy to configure, and cheap. It means low cost. So you don't want to use a cheap name, then it is, you can say less cost or low cost. Okay, so instead of using a cheap. Okay, difficult to troubleshoot. Because line is broken, the communication will stop. Difficult to troubleshoot. Next is a ring topology. What is ring topology? Every device is connected to next device and form a ring. Okay, so next this works based on algorithm. So again, if line or device down, no further communication. Okay, no further communication. Difficult, scalable, and redundancy. No scalability, no redundancy. Mesh topology. What is mesh topology? Every device is connected to
All other devices.
very good with all other devices. All other devices. Redundancy is good. Okay. Highly redundant. Highly redundant or redundancy. Okay, but complex to configure. Lot of wires are there. Difficult. Scalable. Difficult to scalable. So no scalability. No scalability. Complex and cost. Because lot of things are there. Difficult to troubleshoot.
Sir,
Tell me.
sir, what is the meaning of redundant?
Very good. Redundant is actually like a failover type. Okay, so very good. So I will put it here. Redundant.
Scalability too, sir.
Okay, I will tell you.
Thank you.
Failover. Okay, so redundant and failover is like a, if server is down. For example, I've opened a website and it is showing service is not available or server is down. Sorry for your inconvenience. When you go to
Okay.
ATM centers, banking, reservation systems, anything, they said like, server is down, come back later. Sir, when will be open? Anytime it is open, anytime it works. So then do this work. They will tell, it won't work. Government offices, banking people, right? Always they will tell this kind of story.
Yeah.
So
Okay.
here, right? You understand the thing. Server is down, service is not working. But we are working we are going to work in a repeated organizations, right? So client, your client is asking why I'm able to open your website. Server is down. Then your website is won't open. And the guy is asking, so when will it open? It will always open. This kind of answers you will get in a ATM center, banking and all. Same answer you are given to your client. The client will say, no problem, come to the court. I will put your case into consumer form. Okay. So you have to pay a lot of penalty to the client. How to avoid the situation? How to avoid that situation?
Okay.
Understand, right? You
Yeah,
said
sir.
to the client, server is down, service is down. Website is won't open because the server is down. That should not be happen. What I've done, I took a 2 or more servers. 2 or more, I took a 2 or more web servers. Okay. If one server is down, but other server is giving a web service. Understand?
Yeah, sir.
So website means the services keep working even though server is down. How it is possible? Because I have a multiple servers are there. If one server is down, no problem. Other services we are able to access. So that is called a redundancy or a fault tolerance. Main aim of these words are there like that. What are the organization? So whether network failure is occur, maybe server failure is occur, a storage failure is occur. But client should get a service. That is main important. Server can be down, service should not be down. So that is what I'm trying to say. So what is the redundancy? It means keep a extra copy of it, or a extra services, or a extra servers, extra networking components. Even when a service is, whenever the server is down, or a network is down, or a wire is disconnected, still user can able to access the service, or a data, or a network, anything like that. Service should not be down. So to do that one, we need a plan for redundancy, failover clusters, like that. Just one more example I will tell. How many people are using YouTube, Gmail, right? Google searches, TikTok, okay, Facebook, Instagram. Lot of load on those servers. If server is failed, Google server is suddenly stop working. What happened? Crores of people will don't know what to do. They stuck in a traffic also, because we travel a lot of places using Google Maps only. Google Maps server is down. Everybody will stop traveling also, because if they're well known about the line, no problem. The people don't know the line, so immediately they don't know what to do. Okay. So usually, like, you don't get information. So lakhs of people will struck at a road only. So how to avoid the situation? Better to put a multiple servers. If server is down, one server is down, no problem, other server will give you services. So that is a redundancy and fault tolerance. Next one is scalable. Scalable. What is scalability? You can able to extend what are you have. Like you have a desktop. Think about, you have a desktop. You can put a 2 hard disks or 3 hard disks or 4 hard disks inside, right? That is scalable. You can able to add more hard disk in your system. That is scalable. If you have a laptop, can you able to add an extra hard disk? 2 hard disks, 3 hard disks, 4 hard disks internally. Very difficult, right? Not scalable. Not scalable. You can put a multiple RAMs, like one RAM you put it, 2 RAMs you put it, 3 RAMs you put it. Scalable. You can't able to extend. not scalable. 10 computers only I'm using. Only 10 computers can able to communicate. I can't able to put a 11th one like a mesh topology. If I put a 11th one, I have to configure everything. Very difficult to scalable. But in a star topology, you can add as many as computers, and we can extend the topology. Example is in our Pune office, we have a almost like a 3 rooms are main 3 rooms are there. All 3 rooms are connected along with office. Also means the front desk also is connected directly to 3 switches. One room 30 computers, another room 30, around 30 computers, means 25-30 computers we can connect in it. Mainly 2 rooms are there. Okay, so totally like 60 computers we can easily connect. Okay, 60, more than 60 computers we can easily connect through wires. How it is possible? Because 24 port switches, 24 port switches we have. Okay, so one port is given for a internet connection, and another port is connected for a one switch to another switch. So like a 1, 2, 3, 4, 5 ports only for connecting each other purpose, all remaining for computers connection only. It's scalable. Otherwise what happen? I have to stick to the different physical networks only, physical and logical networks only. It is a scalability. It means we can able to extend whatever it is, extending a storage, extending a space, extending a infrastructure. Okay, like this. That is called a scalability. Very good, guys. You are asked again. So what is scalable and redundancy? Because these two words are very important in the network management. Sorry, infrastructure management. Of course, there is one more is there, that is called a load balancer. Okay, one more is there, that is a load balancer. It is very important. In IT, okay, IT infrastructure management. Infrastructure services or management. Okay, so server down, service down kind of stuff should not be happen. Even if server is down, service should not be down. What is the load balancer? Load balancer means lot of traffic increases like a google.com. Lot of people search google.com, youtube.com, facebook.com, right? Lot of people are accessing. So lot of load on the server. Okay, lot of load on the server. So what happens? Server will be crash. Server will be crash if load is very high. So what it will do? It share the load to other servers. Okay, I put a 10 servers. 10 servers share the load. Not enough. Put 100 servers, share the load. So what happened? The load on the server will be reduced. Load on the each individual server will be reduced automatically because of I extend my servers, number of servers, and balance the load on each server. So they will share the load along with the server. So that is a load balancer. So these 3 words are very important is for maintaining the infrastructure. You know, lot of people talk about the cloud computing, virtualization, artificial intelligence, machine learning. You know, there is a lot of big words. People are saying like these big words and saying like that, you have must learn kind of stuff. Of course, there is very important nowadays compulsory for to get a job or maintain like that. But basic important point of how cloud is possible because of failover and load balancing and scalability. These three things are very important factors of a cloud. And of course, cloud has one more extra property that is called elasticity. Cloud has one more property that is elasticity and scalability. Because of elasticity and scalability, cloud is important. If no elasticity or scalability in the cloud, it is useless. How much big cloud you have and there is no scalability and elasticity, and it is not a cloud, it is just a nothing. Okay, it is nothing. You put a lot of money on it, that's it. Okay, that is the main properties of scalability. Whatever the cloud it is, like AWS, Azure, whatever the cloud it is, but the cloud is meaning is it has mainly two properties are there. One is scalability, another one is elasticity. And to another 100% uptime providing only possible because of they follow redundancy and failover. So these are the another important thing. This is a separate one. Elasticity, elastic nature of cloud. This is mainly for cloud. Okay, elastic in nature. This property is there. Okay, guys. So now think this is the out of station kind of stuff. These are a very important. Day one only we should tell to you. Okay. Sometimes we are forget to tell, but you guys are asked again. So without skipping it, that is a good thing. These words are very important. Any doubts, guys, from here, this point?
No, sir.
No, sir.
Very good. So where are we last? It is star topology. Okay, star topology is connecting or connected devices to a centralized devices. To connect devices to central device. So usually hub or a switch. Connect devices to centralized device, hub or a switches. Okay, so like that. Okay, devices in species are communication to hub or a switch or a centralized device. What are the name you put it? Centralized device only. Okay. Generally we use everywhere. This topology we are using, we use everywhere. Okay. It is important is easy to install and configure. Important is easy to troubleshoot. Easy to scalable. Okay, we can extend the topology to higher one. Okay, easy to troubleshoot, but no redundancy. So don't talk about redundancy here. It's a simple. It is okay. How to troubleshoot it? So very simple. Troubleshooting is if bunch of computers are not working, so check it. It is a problem with that switch or hub. If one system is not working, maybe there is a connection issue. Only either wire connection issue or maybe whole device issue. So only two chances. So you can easily understand and troubleshoot it. either hub or a switch problem, you will get it. Or a device or connection issue is there. So that's why it is very easy to troubleshoot. Hybrid is combination of two topologies. So usually star plus mesh topology, we call it as a full mesh topology. Star plus mesh topology, we call it as a full mesh topologies. Point to point. And what is point to point? A device is connected to another device, that is called a point to point. And star type means connecting to switch is also called as hybrid topologies. Okay, what is this P2P? It is point to point topology. What is point to point? Okay, connecting a device or connect a device to other device directly. Okay. Directly we are connecting. It means PC to PC, switch to switch, PC to router, router to router. Okay. Like this, one-to-one connection. So simply say it is point to point. It means one-to-one connection. Okay. Only one is connected to another one. Okay, so mainly used for a WAN communication. Here it is, I have written. So remove it. So why we should keep that. LAN and WAN, but WAN communication is also there. Okay, so point to multi-point communication. Means connecting a device to multiple devices directly. Okay, means a switch to devices router to other routers with a serial connection WAN communication. Okay. Serial communication. The different type of things are there, so don't worry. Point to point means one-to-one direct connection. Point to multi-point means one to many connections. Okay, it is simply say one to many connections. Okay, one to one, it's one to many. Hub and spoke, leaf and spine connections also there. So that is a different type of topologies also there. But important topologies are bus topology, ring topology, mesh topology, star topology, hybrid topology, point to point topology is a very important points. Yeah. Guys, any doubts?
No, sir.
No, sir.
Okay.
No, sir.
So I'm going to stop this recording.